And with that, I would like to open up to any questions or comments that folks might have. Thank you for your time.
Okay, our game plan was to first entertain questions from other speakers, starting with Kate. I think it'd be better if you run up here if you want to have questions. After that, we're going to Steve has microphones. After Kate has any questions, then Len and Tyler, and then we'll open it to the floor in Menlo, and then we'll handle chat and questions. Any questions to speakers? Okay, Kate has a question, getting the speaker to her, getting the mic.
Thanks, Elena. So, quick question. At some point, you mentioned the flagging software will remove outliers in terms of injection volume. I was wondering if you could comment quickly on the concentration dependence of the analyzers and therefore how susceptible it is to the changes in injection volume.
So the analyzers are susceptible to changes in the injection volume. It's a very small change, and so there are two ways to deal with those changes, and it's only necessary if you're really interested in the very highest precision measurements, such as 17XS. So one way is if you have a relatively stable syringe and you have just a few injections that are, say, 10% away from the average injection, to use that flag that would just eliminate those few injections. The other way that's outlined in the paper that I wrote on the 17XS is to actually do an injected volume correction. Again, it's a very small correction, but it does allow you to bring in just that extra little bit for the very highest precision work.
This is regarding the spectral contamination you mentioned. You have shown methanol and ethanol contamination. So what will happen in case of natural organic matter, because they are high molecular compounds, and whether your host software will also take care of those contaminants?
So I appreciate that question. In fact, the contamination is pretty much only seen for molecules that have an OH group. So this region of the spectrum that you see here is a region where you have an OH stretch, which is what's causing this absorption. So things like methanol, ethanol, hydrogen peroxide, which have OH groups, tend to absorb in this region. Most other organics that do not have OH groups will not tend to absorb in this region, and so they will not cause any spectral contamination. Because we have the high resolution spectrum, we're not looking for specific molecules. We're looking for changes in the spectrum. And every spectrum is saved on all of our instruments going back. So anybody who has old instruments, has old data that they want to check, can open up their old data and check it. It's all there, all the spectra are there. And it doesn't look, like I said, for a specific molecule, only for any changes in the spectrum. Larger molecules that do have OH groups tend to behave like ethanol and make this change, and that we can definitely see.
There are some applications of looking at water in plants or soil, and right now I understand you have to do extractions offline in order to analyze that. Is there any plan to do a online extraction from soil and
There's my question. Just type it in.
I'm sorry, I'm not sure I understand the question. Are you asking me if LGR is planning to have an extractor?
Yeah, an extractor attached to your instrument such that you can use your soil.
Elena, please repeat the questions because we can't hear it from the phone.
So the question was whether LGR is planning to offer an extractor as a peripheral to the instrument, and that is not something that we are planning to do right now. We are focusing on the other issues that I suggested.
Let's open this to the questions sent in by people by chat and email. Rick, are you handling that?
Yes, I do. So I have one question from Ben Grawler. At the WVISS, what would be the minimum time for switching between two different standards? Did you hear that?
Yes, I'm trying to see if I remember the answer to the question. I believe it's approximately a minute to switch between them. It depends. There is some time in the instrument. I would need to know, the question is switching between two vapor samples or actually changing the isotope standard in the WVSS, changing the bottle to a different bottle. If you're going to change the water, then the nebulizer inside the WVISS would need time to equilibrate with the new water. So that takes several minutes. If the question is just switching between vapor sources, that happens much faster.
Okay. Then one question from James Farland. How long does it take to switch the system from liquid water to water vapor? Are there any problems with a memory effect when switching between the two operational modes?
Thanks. I'm sorry that I didn't mention that. The instrument switches from liquid water to water vapor quite easily. It's just simply a change in the code, the software that's running on the instrument. So you just have to shut down the liquid software, turn on the water vapor software, and the instrument is converted. And the memory would have no different effect than it would if you continued to run in the mode that you were running in. So whatever sample you had used last in the liquid water mode, whatever concern you had about that, the memory from that sample over to the next liquid water sample would be the same amount of concern you have for switching to water vapor.
Okay. Then the next question is, in a highly humid region, H2O greater than 30,000 ppm, do we need any kind of correction in vapor isotope data?
You certainly wouldn't need a correction. The instrument can measure at those highly humid levels. The one concern that I would have is that you would need to make sure that the lines weren't condensing into the instrument. Our newest instruments are temperature stabilized and they are heated, so you wouldn't expect any condensing inside the instruments at 30,000 ppm. But researchers would need to be careful with getting the vapor stream into the instrument. The condensing didn't happen between the source and the inlet to the instrument, as of course condensing would cause large errors in isotope ratios. Okay. Okay. Understood. Then the final question I have is from Ty Copeland. What is the plan for compatibility with LIMS, Laboratory Information Management Systems, to laser specs used by laboratories in at least 10 countries? And I'm suspecting that means in traditional mass spec, IAEA kinds of things, that there's a standard LIMS for that. Yes, of course. LGR is very sensitive that there are a lot of labs who rely heavily on LIMS for their data management. And as soon as the LIMS software is available to include the 17 isotope, we're working very hard to make sure that our instruments are compatible with that and that all laboratories will have seamless use between the LGR instrument and the LIMS database.
Okay, very good. That's all I have from the chat box, Carol.
Okay. In Menlo Park, are there any more questions? It doesn't look like it. We are more than 10 minutes ahead of time, so I propose a 10-minute break. We'll get back at... Oh, there's a question. Sorry. Somebody has a question.
The conference is no longer in lecture mode. The conference is in lecture mode.
Got a break?
All right, there appears to be a question from Kathy Tate asking about the precision of 17-access for natural samples. We expect that the precision on the 17-access for natural samples is the same as those for the standards that we have tested. We have several groups that have been using the instrument, and we haven't heard anything differently from that. So I am very confident in the instrument. I have done my own research as well on this, and while it's not published, at least that I haven't published it, the precision, available precision is the same for all of the clean water samples.